Consider the differential equation y double prime plus y is equal to 0. So we know that there are two solutions to this equation. y1 is equal to c1 cosine of x, and y2 is equal to c2 sine of x. So now let c1 equal 2 and c2 equal negative 3, and consider y equal 2 cosine of x minus 3 sine of x. So let's plug this y back into the differential equation and see what we get. So we take the second derivative of 2 cosine x minus 3 sine of x. And then we have plus our y, which is plus 2 cosine x minus 3 sine of x. So when we take the derivative of sines and cosines, we get back sines and cosines, except with a negative. This is the second derivative. So we get negative 2 cosine x plus 3 sine of x plus 2 cosine of x minus 3 sine of x. So what we see here is that our cosines will cancel out and our sines will cancel out down here. So cancel, cancel, sines cancel. So this is equal to 0. So in fact, this y is also a solution to the differential equation. So, and it really didn't matter, since our 3 canceled out with the sign and our 2 stayed over here, it really didn't matter that we had 2's or negative 3's, it all just canceled. So what we call this is the principle of linear superposition, and it says that if we have a linear homogeneous differential equation, then any linear combination of solutions to that differential equation will also be a solution to the differential equation. So let me just write out what we're saying here. So this is called the principle of linear superposition. Okay, so, and this is for, again, this is for homogeneous and linear differential equations. So of the form d squared y dx squared plus p of x dy dx plus q of x y is equal to 0. So this is linear, there are no cross terms with y's, and it's homogeneous because it's equal to 0. And so let y1 and y2 be solutions. Then y equal to c1 y1 plus c2 y2 is also a solution. So what we should do is just plug in y here to actually see if this is in fact a solution to our differential equation. Plugging this in to here, we get d2 dx of c1 y1 plus c2 y2 plus p of x times our derivative dx of c1 y1 plus c2 y2 plus q of x times c1 y1 plus c2 y2. Now if we group the parts of this equation with all the terms that have c1 and all the terms that have c2 together, so we start with grouping c1, we get c1 times d dx of d2 dx squared of y1 plus p of x times dy1 dx plus q of x times y1. And then we have plus c2 d2y2 dx squared plus p of x times dy2 dx plus q of x y2. And we notice that this is just the original equation, but with y1 plugged in, and y1 is the solution, which means this is equal to 0. Again, we have y2 plugged into our differential equation. y2 is the solution, so this is also equal to 0 here. So this whole thing is equal to 0. So it didn't matter what C1 and C2 are because they ended up pulling out. So this being able to find new solutions using linear combinations of your known solutions is called the principle of linear superposition.